If every human somehow vanished from the Earth, how long would the last artificial light source stay on? Starting with the obvious, most lights wouldn't last long because major power grids would fail quickly. Even though demand for power would decrease without people, appliances like fridges, air conditioners, and lava lamps would still operate. Fossil fuel plants, which provide the majority of the world's electricity, require a constant supply of fuel involving human activity. As coal and oil plants shut down within hours, other power sources would face extra load. This situation is challenging to manage even with human guidance, leading to a series of cascading failures and blackouts of major power grids. Nuclear reactors don't need a constant fuel supply and could run almost indefinitely if their cores settled into low power mode. A uranium cube contains about 6 million times more stored energy than a similarly sized coal cube. However, most nuclear reactors wouldn't continue running for long. Any malfunction would trigger an automatic shutdown, designed to happen rapidly upon failure. The most likely cause would be the power grid failure. Many light sources are not connected to major power grids. Let's explore when these might turn off. Remote communities, like those on far-flung islands, use diesel generators that run until their fuel tanks empty, which could take days to months. Off-grid generating stations without human-provided fuel supply would last longer. Geothermal plants can run for some time without human intervention. According to the maintenance schedule for the Svartsengi Island geothermal plant, operators must change gearbox oil and re-grease motors and couplings every 6 months. Without such maintenance, these plants might last a few years before succumbing to corrosion. Wind-powered lights could last even longer. Wind turbines are designed for minimal maintenance due to their quantity and inaccessibility. The Gedser wind turbine in Denmark, installed in the late 1950s, generated power for 11 years without maintenance. Modern turbines are typically rated for 3 years without servicing, with some possibly lasting decades, including at least a status LED. Wind turbines and geothermal plants would eventually stop due to gearbox seizures. Hydroelectric generators would also keep working. An operator at the Hoover Dam mentioned that the facility would run on autopilot for several years if abandoned. Without a functional power grid, electricity from these dams would have nowhere to go, leading to mechanical failure from clogged intakes or similar issues. Battery-powered lights wouldn't last long either, discharging within a few decades. Batteries eventually self-discharge, even without usage. Long shelf-life batteries typically hold a charge for only a decade or two. Solar power is a promising candidate. Numerous off-grid solar-powered buildings, weather stations, and other remote infrastructure exist worldwide. Emergency call boxes along remote roads are often solar-powered, providing nightly illumination. Built for longevity due to their inaccessibility, solar panels can last as long as their connected electronics are kept clean of dust and debris. In dry places with well-built electronics, solar panels could provide power for a century, aided by occasional breezes or rain. Strictly speaking, solar-powered lights in remote locations could be the last surviving human light source. However, there's another unusual contender: spent nuclear fuel. Contrary to popular belief, radioactivity isn't typically visible, necessitating warning signs around radioactive materials or waste. While radium-coated watch dials glowed in the dark due to phosphorescent paint, the glow wasn't from the radioactivity itself, but from the irradiated paint. Once the paint degrades, the dials remain radioactive but no longer glow. When radioactive particles travel through materials like water or glass, they emit light through an optical sonic boom called Cherenkov radiation, visible as the blue glow in nuclear reactor cores.
Some radioactive waste, like cesium-137, is mixed with glass, cooling into solid blocks before being shielded for transport and storage. These glass blocks glow blue in the dark. Cesium-137, with a half-life of 30 years, means that even after 2 centuries, the blocks will glow with 1% of their initial radioactivity. The glow's color, determined by particle decay energy, remains blue as the brightness fades. Therefore, centuries from now, deep in concrete vaults, the light from our most toxic waste will still shine. For more videos like this, please subscribe and hit the bell icon.